Without further ado, let's get into today's seminar. The first topic that we have up is AI for workplace safety. So, a very specific area, workplace safety, in which AI is being used. And we have speaking for this, Mr. Manik Bandari, who is the CEO of Vulcan AI. Manik is a serial intrapreneur. Okay, I'll let him explain what an intrapreneur is. And he's now an entrepreneur. Okay, and he set up and successfully scaled analytics and AI practices for Accenture when he was working there, and then subsequently with EY Ernst and Young before founding his current outfit, Vulcan AI. So without further ado, let me hand you over to Manik.
Thanks, Brian, and a happy new year to all the attendees. Today, I will be talking about AI and how AI is being used for workplace safety. I'll keep it short. So I think, fortunately, these accidents don't happen every day, but they do happen. And a lot of times when investigation is done, what the main root cause seems to be that, everybody makes assumptions that, somebody's taking care of things, and we make these assumptions, and then we're not alert or we're tired, and then these accidents happen. For instance, in this example, it is about the supervisor thinks, I assume that everybody is wearing a safety harness when they're doing construction work, but in reality people sometimes don't do that to cut corners, and then accidents may happen. And we think it will not happen to us, but as we know, it can happen to anybody. So to address some of these things, there was a Workplace Safety Act which was passed a few years back, and the purpose really and the guiding principles are how to reduce risks, because there is no place which is 100% safe. Even if when you in your own home, when you're taking a shower, you can slip, you can fall. The world is a dangerous place, right? So how do we reduce these risks? We cannot eliminate, but can we reduce these risks and also instill a greater feeling of ownership around safety and health outcomes? And if accidents do happen because of neglect and willful negligence, then there should be penalties for poor safety management. So the act basically does a few things. It puts the responsibility of workplace safety on all the stakeholders. So if you're, for instance, if you're a mall operator, then not just the landlord, but the facility management company and the cleaners and everybody can be responsible if something happens. So it's a collective responsibility for all stakeholders to make sure the place is safe. Then it focuses on outcomes, and the outcomes can be quantified in terms of number of accidents that have happened either in a year or per individual who's working there. And then also when these accidents happen, people can be put on surveillance. Companies for more active sort of monitoring to make sure that they don't repeat that behavior. So more and more we are taking, and Singapore especially is taking workplace safety quite seriously. There are penalties, but I think more than penalties, we owe it to the people who work in our companies to give them a safe environment. And I'm just listing some of the common things which happen. Even if if you're a white collar worker, and you work mostly in front of a computer, but some of these things can happen, like slip, trip, falls. When you go to the toilet, the floor may be wet, you may slip and you may fall. So these things can happen to anybody. So slip, trip, falls are actually quite common. You will be surprised to know that every year there are a few thousand of these incidents which happen in Singapore. You could do a few things like keeping things dry, good housekeeping, good lighting, non-slip footwear. You can do that. And what I wanted to quickly pivot to was how AI and IoT is being used by some of these facility management companies to do slip, trip, fall prevention as well as detection. So this terminology, STF, is actually quite common in the safety industry. So these are, just some statistics in terms of fatal work injuries. As you can see, falls from height is a major one, vehicle related, machinery related. Slips, trips, and fall continues to be one which sounds very very trivial, but it can still have fatal work injuries. And when you look at the major injuries, there's 150, 170, and these are just in one industry. So it's quite a big topic. So the way this project was done was it was a combination of wearable technology. So it could be like a Fitbit or a wearable which you wear on your wrist. And then there is a CCTV cameras also. So both of this data sources are sort of combined, and the AI detects whenever there is a near miss. So a slip or a trip is actually called a near miss. The idea of using two sensors was that, when you go to toilets, obviously there won't be any cameras there for privacy reasons. So in the facility management industry, a lot of cleaners are quite elderly, and they may have frail bones, and they're at higher risk. So for these higher risk individuals, we give them the variable so that even if they slip a little bit, then we can catch that, and then we send an alert to the supervisor, and the supervisor can check on the safety of that person. And also a near miss or a slip could indicate that floor is wet there. So it's also useful in identifying hazardous areas where some mopping can actually dry it out and make it safer for other people. So I'll just quickly show you the demo of the solution which some of these companies are using. Here, so this is a variable, so it's not expensive Apple Watch kind of a variable. It's a very simple variable which has accelerometer data, and accelerometer data is essentially just how motion is being tracked in 3 dimensions. So X, Y, Z dimensions. How are you moving? So based on the unique motions of your hands, when you slip or you fall, your hand goes up like this. That data is immediately captured from that variable. So in the morning, the workers or the cleaners come in, there is an app, they check it in, and they say, I'm syncing my variable, I give permission to sync my variable data with this app. It's checked in. Then what you see on the right side is one of our own office person simulating it. So he slipped, and the variable detects that, and then it sends a notification to the WorkSafe app, which the supervisor may have. So instead of keeping the app running all the time, you get a notification, it shows you there, and then the supervisor can actually see that and investigate and then record that, like why it happened or some action needs to be taken. So that's the idea. So just an example of how variable data is being used. I'm going to show you another example. This is a plant in Singapore which is used to sort out disposal rubbish and garbage into different recyclable and recyclable ones. So it's very dangerous environment. As you can see, there's a bulldozer there. Sometimes it rains. When the rubbish comes, it can be wet. So it's a slippery area. So they put a camera there, and the AI actually then looks at it. And then whenever the video doesn't seem to be playing for some reason. Anyway, so what you would have seen in the video is that the person is moving, and then you actually detect a slip, and then the AI then sends a signal. So these are just other examples of slip, trip, falls being detected. So on the bottom side, you're seeing a person walking with a phone in his hand. There is a box there, and he trips on it. But then as soon as you trip on it in the office, it identifies it as a trip, and then you basically get an alert that some accident may have happened. So this is a field called video analytics. Their techniques are around deep learning and AI, which are used in this thing. Okay. The way it works is basically variable data comes in. There is some models, RNN, LSTM models, which are used for the more technically savvy. I mean, you would know that. For the camera, what happens is you first detect a person, and then all the points on your body, which are called key points, are detected, and then the relative motion of those points, the AI then classifies it into different incidents. So these are, I mean, I'll skip this actually, but basically the second example, I will show you how some of the shipping lines are using this technology. So if you look at the shipping industry, actually some of the ships are really big, and this is just a picture of that. They could be 400 meters long. They're just manned by 20 people. It's a very high risk environment, and sometimes you work alone. So if you're going at night and you're working alone, it's a confined space. You slip on a ladder, you fall down. Actually, nobody may know that that this has happened, and then you may be needing help. So, and just that 30-minute difference in response time could be a difference between life and death. So they're looking at automated ways of detecting and alerting for hazards. The good thing is the ships are now quite digitized. There are CCTV cameras there, and people can wear wearables. All that sensor data piped through AI and then generating alerts. So same concept. And this is an example of how sort of even big companies like Microsoft are now developing these devices, edge devices, which don't need to be connected to the internet, but they can be just plugged into their CCTV system. and the AI is preloaded on it, and it can do things like whether the worker is wearing the boots or not, are they wearing gloves, safety harness, or helmet. So when you go to work, it checks whether you're all kitted out and you got everything. The second thing it does is same thing. If you slip down the stairs, you fall down, fall from heights, or you're struck by a moving object, it can detect that. Then also hazard. So if your trip plate is loose, so anything which changes in the background, like the normal is this, but the abnormal is something like this, it can detect those AI and then send alerts. So I'm not sure the full video. We're running out of time. But here's an example where somebody in our office, so the AI detects it as a person, so you can see that. And when the person wears this, it basically says, hey, you still have not worn the vest, so please wear your vest. When he takes out the helmet, it detects the person is not wearing a helmet and vest. Then as he starts wearing it, then you will see the warning for the helmet and for the vest will go out, and then the warning for the helmet will sort of still be there. Now, once he wears the helmet also, basically all warnings will go away. So this is an example of, we're doing AI to detect a few things. One is the person, are they wearing the right PPE or not? In the COVID-19 setting, you can also use it for people wearing masks or not, but basically using existing CCTV to improve workplace safety and health. The other thing is the wearable stuff which we showed them. So heart rate and other concepts can also be checked, like vitals if you're fatigued. And a lot of times the research shows that if you're tired, you're more susceptible to an accident at work. So I will stop now and thank you for listening. Thanks for taking the time. I'll give the time to the next speaker. There's a Q&A, so if you would like to put some questions in the Q&A, please put it and then we will come back to the questions later. Thank you.
Thank you, Manik, for interesting session to start us off. I think very practical examples given on how AI is used in workplace. Next up, we have a topic on big data and AI in accounting. And we have Lin Zishen from Nomura Asia. He's the Executive Director of Finance, Transformation, and Change Management. Zishen is very active in this area. He brings with him 15 years of experience in financial services, has an MBA from London Business School, is a qualified accountant, and has worked in London, Hong Kong, and Singapore. He started in Citigroup and has also worked for Credit Suisse, HSBC, and finally Nomura. In his current role, he's responsible for using technology to help transform the finance function globally. And so he's one guy who's been using or looking at and using big data and AI in finance for accounting for quite some time. So welcome, Zishen, and over to you.
Thank you, Brian. Let me share my screen. Can you share my screen? Okay.
Yes.
Yeah, I'm not going to be as visual and interesting as Manik, because obviously I think big data and AI is a lot more advanced in his area compared to the accounting world. So I'm going to talk a little bit more something that's more aspirational and more I will say we are not that advanced. So, but I think there's a clear roadmap of how we're going to get there. So I'm going to talk more about that. So let me go through. In my work, quite often you find that one of the challenge in transformation is always convincing people that the industry is changing and needs to be. We need to look ahead. And so some interesting pictures and some interesting jobs that have disappeared. And I think the key point about all this is that big data, which ultimately for accounting, for finance, is about data analytics. Big data and AI will significantly change, I would say, the competitiveness of businesses. And also, of course, with that will change the nature of accounting. So I'm going to talk about today is more around how this will impact the accounting industry, how I see it transforming, and obviously why do you want to transform, and talk a little bit about a roadmap of how you will see a usual accounting practice transform from where they are now to the future. And the last bit is where I give examples of where things like AI and data analytics are applied. What are some of the opportunities, and also look at some of the challenges of trying to implement this now. I mean, the progress is quite slow in a lot of firms simply because there are challenges. So I think there's a lot of interest in big data, in AI, in data analytics, simply because all these technologies will change the way the companies compete, and of course the way accountants work. On the company side, you find that technology actually introduced new competition. We saw all the new competitors to the banks, the digital banks, the WeChat, Alipay. But on the other hand, you also offer new opportunities for incumbents, which I'll talk a lot more about in the last slide on how companies and banks can leverage some of this in new opportunities. And for the accountants, I think what is interesting is if you look at what accountants typically do now, it's pretty mundane, pretty boring, produce financial statements, management reporting and stuff like that. But I think technology is going to hopefully change the way we work. And to be fair, it's not just about that, it's also change the work we do. It means the nature of the work that we do will change. Firstly, I think you automate and create efficiencies. A lot of the boring stuff that we do now should be automatable. And what's more important, this is the creating new work, which is allowing accountants to add value. And again, I'll explain later what does that mean in terms of adding value. And of course, with that, it opens up new job opportunities. Increasingly, you see terms like data analysts and all that in accounting hires and all that. And so that's the new job opportunities. And what is the ideal transformation that we obviously want to do is, this is the current state where a lot of firm accounting functions are involved in operations, basically producing reports, MI submissions, regulatory submissions, financial statements. Very little time spent on really adding value. And it's every CFO dream, obviously, to then move to this inverted triangle, where you want to spend more time on analytics and less time on operations. And to do that, effectively, there's two key things you need to do, right? One, obviously, you need to automate, and that's where AI comes in, helping you to automate your operations. And two is obviously you want to add value, and where does accountants add value is really in this area of data analytics, right? And that's where, again, big data AI comes in. So that ultimately is what I think accounting profession aims to do, right? Reduce their operations and increase their value add. And this is a very interesting, more in-depth look at that same concept. We actually, when we first started this transformation journey, we got some leading tech firm to come in and give us talk about how they run their finance function. And this is what they presented, which was, I think, is very interesting and insightful. So obviously, the tech firm start off by cleaning up the data, because obviously you cannot do AI or data analytics without having clean data. So they clean up the data. And like any other firm, accounting firm, finance function, everybody starts off from here, right? In fact, we are still quite substantially here. A lot of manual process, Excel processes, and they then went on to automate those processes, put them into interactive dashboards, so that you can move from just producing information to analyzing information in interactive dashboard, and they then move on to predictive and information. So they cite example. They actually used AI to predict their revenue forecast, and they find it more accurate than asking their salespeople for the forecast, because obviously salespeople tend to have incentive to skew the numbers. So the machine learning algorithms that they use to generate the forecast was more accurate, which then they can use it for going out to the market and explaining to the market analysts about their predictions of their numbers. And they also have other things that they do, like things like chatbot to answer queries from on finance matters and stuff like that. So they are moving towards it. They're quite far advanced in terms of this area. And to be fair, for a lot of us, we are still somewhere here. We are focusing more on automating our manual processes, and some of this involve applying AI to do the automation. But we are not as much yet on this bit of using AI to do predictive data analytics. But that's the end goal. Obviously, the whole purpose of this is you want to move from the production at this bottom to value add at the top, right? And that helps to drive the decision. So now I'll talk about the opportunities and then I'll talk about the challenges. So as mentioned, this I would say is the opportunity in a way to transform once in a lifetime for the accounting profession. As accountants, what does AI and big data need is obviously data. And as accountants, we are custodians of data. I mean, in every firm, is the finance functions, the accountants that it keeps the most important information, the finance information, to some extent, we even have the HR information, all the other information that's important. And so as custodian of this information, accountants can make use of the technology that's available, increasingly available to create value. And that's what is key in this, right? That's the opportunity. So let's go through three categories of what a firm is interested in. Obviously, a firm wants to increase the revenue, we want to reduce costs, and we want to increase control. Some examples of how we can increase revenue. With the information that we have, we can help the firm understand the customer, and you could look at, let's say, if you're a consumer bank, you could look at the spending patterns of your customer and be able to recommend the person the right products at the right time, right? So if the person has children, and you know a holiday is coming, you might want to offer them travel insurance or something like that. So you find that you could using the data generate a lot of cross-selling, and that's the real power of data analytics, is the ability to understand your customer and generate additional revenue. As I mentioned, we talked about the tech firm. They use the AI to generate their revenue forecast. For most of us, I think we're still on this area first. Our accounting functions haven't really gone to this area of looking at this. I mean, we do help the fund line look at some of their costs and all that, but not so much on the revenue side. But on the cost side, again, the same data can be used to understand your costs. You can look at how much you spend by supplier, where's the spend. You can look at your spend by your employee and all that. And you can also reduce your cost of processing, right? Because obviously you could use AI technology to help you automate a lot of your reconciliation, break investigation. Even simple things like OCR is a form of AI, because you're trying to match your invoice and converting them to from a photocopy document or scan document into text and then matching them and all that. As I mentioned, you can also have chatbot to help you answer questions, first level kind of questions on maybe financial policy, HR policy, and stuff like that. And also, this is I guess one of the big areas that a lot of companies are focusing on initially, using it to improve controls. You can use AI to help detect anomalies. Let's say when I'm doing I'm publishing my financial statements, obviously I want to make sure it's right. Currently we look at it visually or check, by having some simple this submission versus last submission calculation. But you could use AI to help you look for some of this anomaly, and especially if it gets a much bigger reporting, or that you find that AI can help you. You can also look at unusual duplicate payments. I think my time is up, so I'm going to speed up. And also you can even get automated regulatory news update from the regular website without having you to go and search through them yourself. But what's the challenges? In order for you to be able to do all that, you need to firstly have the data, as I mentioned earlier. So you find that in a lot of firms, data are usually not easily accessible or in different locations. And secondly, data are not usually clean. That means it's not something that you can just take and do your beautiful stuff with it. You need to clean it first. On the other hand, the mitigating factor is actually there are tools and technologies out there that helps you address some of these issues. Of course, the data lake, pretty expensive if you want to embark on it. There are ways to work around it, such as data virtualization. And also there are visualization tools like Power BI and Tableau that helps you to collect data from different sources and try to visualize them. I think the second key challenge a lot of firms have is, beside the data, is the skills. You need people who are able to actually use this data, people who are able to implement machine learning models, people who are even able to do simple data analytics. First, again, the mitigating factors are, firstly, I think a lot of industry providers are providing training already. All the accounting profession bodies and all that are starting to do the level 1 of this, which is the basic data analytics. Not the machine learning or that's too much, but they're all starting with the basics. So there's training available. But for more sophisticated solutions, you might want to consider engaging vendors to deliver them. And with that, I end the thing. I think, yeah, just nice 10 minutes. Let me pass over to the next speaker.
Thank you so much, Sichen. I think we have a good discussion coming up with you, especially on the use for AI in finance. Obviously, with the amount of data that the finance industry has, the potential is there, but obviously, like you pointed out, the skill sets will need to be there, and certain other considerations also need to be made. Keeping still, I think, with the financial industry, we have Chuang Xin who is a CEO and co-founder of Pan AI, who's going to be talking about big data and AI, specifically the banking part of the financial industry, so the banking industry. Pan AI is an AI chatbot specialist for financial services working in the Southeast Asia region. Xinvi was previously the head of digital banking for Standard Chartered Bank in China, and he's a graduate of MIT and the Wharton School at the University of Pennsylvania. So without further ado, Xinvi, it's all yours.
Thank you, Brian. So let me share my screen. All right, so so for the purpose of this conversation, since I'm no longer working in banking, so instead of giving you a whole bunch of the strategies of what banks are going to be doing, I thought I'll just show you some demos of what financial institutions have been doing with AI. Now, AI on its own is very broad. And within AI, what my company and I are focusing on is this thing called natural language processing, or NLP. The NLP engine turns human languages into commands that machines can understand, so that you, for example, don't have to learn how to write an SQL query. So as I said, I'm going to show you some demos, and specifically 2 demos. And if time permits, I'm going to show you a third demo. So the first demo that I'm going to show you is about how a relationship managers from a bank can use an AI tool, in this case, a chatbot powered by natural language processing engine, to assess in mutual fund or product or mutual fund informations, to analyze performance across 2 products, and to learn some market insights. So imagine if you're a relationship managers, this could be one of the questions, one of the very common questions that you'll be asking on a day-to-day basis. So something like, say, what is the NAV? NAV, of course, stands for net asset values of, let's say, Schroders Asian Growth Fund. Now, so I type in a very simple questions, what is the NAV of Schroders Asian Growth Fund? And you notice that the chatbot in this case asked me a clarifying questions. It's asking me which share class am I referring to. Now, the reason for that is because the AI spits it up and understand that my questions is actually ambiguous or at least incomplete. Because share class NAV is defined at the share class level, not at the fund level. So so it asked me to clarify whether I want to look for SGD share class or a USD share class. Oops, sorry. Yeah, sorry, there's a hiccup here. So in this case, what it does is it tells me that the NAV of Schroders Asian Growth Fund is this much. And of course, there is some predictive AI that we're building, so that, you know, at the bottom you see some buttons that are essentially attributes related to this particular funds that a lot of people query. So we built in a simple recommendation engine, so anyone can just click, instead of asking questions entirely, can just click a button and to get these informations. I can also ask questions like they are not listed as one of the buttons. For example, who is the fund managers? Now notice here, I did not ask who is the fund managers of Schroders Asian Growth Fund. What I asked was who is the fund managers, simply as simple as that. Now the reason for that is because again, AI kicks in. There is a contextual memory that we built in for which that mimics conversations between the users and the machines, and make it as if it is a conversation between two human beings, so that if I'm talking to a human and I was inquiring about this particular fund and I ask who's the fund managers, the natural intuitions is that I'll be asking for who is the fund managers of this particular fund, and this is how this comes about. The next thing I'm going to show you is something that I find fairly cool, is called a fund card. Oops, sorry. Now, I'm not sure if you can see the pictures here, but what I do have here is an infographics that essentially shows all the information related to this particular fund. Over here. And then what you can do is to really go a step deeper, to really compare and analyze across two different products. So I could simply, ask the questions, compare with XR Asian Growth Fund, let's say. Oh, okay. My apologies. Let me try again. Okay, I'm not able to show this these features right now. So let me toggle next to another features, which is show me all in USD by say BlackRock. Now, what is happening now is that I'm asking a relatively complex questions, which is what is show me all the fixed income funds in US dollars by this asset management company. And notice that the AI is able to pick out the key attributes in my sentence. So currency, in terms of currency, it'll be US dollars. In terms of branding, it'll be BlackRock. In terms of asset class, it'll be fixed income. And so this shows how the NLP actually progresses over the years, and such that you can even ask questions like, do you have any articles or insight about China? That you not only could ask simple questions for text-based response, you can actually also, pull out articles related to the topics that you'll be interested to learn. So this is my first demo. The second demo that I'm going to show you is about how a senior executive can get very targeted and detailed information about the financial performance of his company. Now, the example I use here is a telco with dummy data. But at the end of the demo, you should be able to imagine how it can be easily extended to other verticals, including banking, including insurance, and others, and other industries. So the questions that we'll ask here, let's say, is what is the revenue for what? Okay, let's say what is the revenue in June 2018? I think I need to refresh this. What is the revenue June 2018? All right, and it will tell you that total revenue for June 2018 is this much. The AI is able to pick out that I'm looking for revenue in June 2018, even though I spell June with JUN and not a full sentence. And you notice here again, we have some buttons at the bottom to shows more details. So in this case, the board display revenue in terms of Malaysian ringgit, but I can also ask for it to be displayed in US dollars. I can also click on more analysis, and it should be able to show me that a simple chart of of its revenue trend over the past 3 months. And I can also say, click another KPI and look for, more attributes. Let's say IT costs. And again, it's able to show me the IT cost for June 2018 is this much. I can also ask questions like, highest revenue in 2018. And the AI behind would then go through a giant database and calculate and find the highest revenue month for 2018 and show me that is indeed it is in fact November 2018, and it shows me the revenue for that particular month. I can also ask more complicated questions like compare manpower costs between October 2019 and December 2019. And again, it will show me that the difference between the cost between December 2019 and October 2019 is this much, even though again, I was writing in partially complete and partially incomplete spelling for months, and it shows me this particular chart. I can also be a little bit more playful, and instead of just asking for month, I can ask something that is more akin to how finance people would be asking, like what is the bad debt percentage in Q2 2018. Again, it's able to show Q2 for 2018 is this much. I can also ask what is the bad debt percentage in H1 2018. Again, it will show the past 6 months. The first 6 months of 2018. I can ask questions that involves calculations. So what is the cost income ratio for H1 2018? This will show the cost income ratio for it will first of all calculate the average monthly cost to income ratio, and then it will have a chart for me to get into more details if I want to. And you can also ask, you can also ask questions like what is the lowest revenue type for Q4 2018. and it will display a table to tell you this is you know, the revenue type is, the lowest revenue type is this much, and it contributes 1.7% of total revenue. I can also ask questions like what is the ratio of prepaid to postpaid customers for October 18 to March 19. Again, you know, the AI will be able to recognize the different types of dates that are commonly associated with how people would use it. And finally, I can, you know, get a bot to answer questions like, show me the trend on prepaid ARPU. And you will ask me to calculate to find a date range. Let's say I go for the past 12 months, and again it will show me the chart. Now, all right. So this is what I have. Do I have more time, or is my time up?
Shinwi, I think we can spare you a couple more minutes.
All right, so what I'm going to show next is something hopefully more interesting. Let me see. I'm trying to get rid of. It's something that is fairly cool. It's not mainstream yet. It is something what the data science, what the AI community call machine comprehensions. So I just took a snippet of a news articles from today, whereby the Malaysian Kings declared a state of emergency, and what I did was I copied a paragraph into this thing, and what I'm going to show you is how, without putting together a lot of complex database engineering, I can simply use this AI tool called machine comprehensions to ask the questions. Like in this case, I can ask questions like, how did the king make his decisions? Effectively, I'm looking at the first sentence. The king's decision was made was also based on data showing how the healthcare system was under logistical constraint, the statement said. So when I ask the question, how did the king make his decisions? The answer is based on data showing how the healthcare system was under logistical constraints. So this is the futures of NLP. As I said, it's still not mainstream yet, but we have people, we know of people looking at this area, and clients finding it enormously useful when it comes to applying this new AI technologies for both for the internal workflow as well as for customer-facing functions. So I guess with that, that's come to the end of my presentation. Thank you very much.
Thank you there again, Shinbi. I think very interesting, a little bit of showing us some of the technology and some of the examples that AI is being applied right now and in the near future in banking, and as well as some of the finance functions within corporates. So what we're going to do now is we've got a couple of activities. First off, we have a poll to kind of create a word cloud, okay? And I'm going to mention this to kind of keep you interested. We have a couple of activities which the audience can participate in. At the end of this session, we have a prize for the best participant of this activity. So you want to stay tuned to that. But first, let's do this quick poll that we have to create a word cloud. And the question here is, what word comes to mind when you think of big data and AI? Okay, or what word or words come to mind. You can have more than one when you think of big data and AI. Okay, so you can join in three ways. One, you can click on that link on your computer, the menti.com link. Two, you can scan the QR code and get to that. Or you can go straight to menti.com and key in this code number 4221357. Okay, so let's create that word cloud. And I'm going to give you a couple of minutes to do that. Okay, for those who need to take a bio break, now's a good time to do that. I think we are going to spend the next couple of minutes. You can either key in your word cloud or you can take your bio break before or after that. And we'll see you in a couple of minutes. So I'm going to leave this on while I also go into this word cloud. Very good. So your code is, remember, 4221357. Okay, what words come to mind when you think of big data and AI? Very good. Keep those words coming in. Okay, very good. Okay, remember you can go to menti.com, use the code 4221357. Okay, automation is leading the way, robotics, quite close, machine learning, cloud, analysis, big data, obviously, privacy, efficiency, intelligence prediction, okay, predictable analysis. Hey, I think roughly about a third of you have participated in this. Don't give up yet. Keep going. Thank you. Some more people coming in. If you are going to head off for your bio break, you have, I think, another 4 minutes to do so. 40 people have contributed. Okay. More contributions, but the word cloud hasn't changed much. Thank you. Thank you. We have 2 minutes to go for your bio break if you want to make a quick dash. Okay, 1 minute to go for your bio break. And we'll also close the menti.com submission then. 46 people have contributed. Great. All right, thank you very much for contributing to the word cloud. I think we have a bunch of words that are there that are going to be very useful when we get to the panel. Thank you again for participating. I hope you've managed to get your bio break because we are going to proceed with the rest of our sessions. I think we have another 2 speakers and then we move on to the panel. So let's keep this going. Next up, we have Suraj Kamath, who is the director leading industrial AIoT solutions practice for ASEAN at SAS. He develops go-to-market strategies and provides leadership and guidance on AIoT solutions for industries across manufacturing, utilities, smart cities, and others. He has over 12 years of experience across precision engineering, semiconductor manufacturing, industrial 3D printing, and others. And he's enabled companies and customers to improve process control, increase yield, reduce waste, optimize pricing and product mix, and develop successful business strategy. Suraj is going to be speaking on big data and AI for use in the manufacturing industry. So I'm going to hand you over to Suraj. It's all yours.
Thank you, Brian, for that introduction. Just give me a second to pull up my slides. And of course, it wouldn't start on the right page. Brian, could you tell me if you can see my slides?
I can.
Perfect.
Yes,
thank you.
You're on the correct page.
Wonderful. Thank you. So thanks for the introduction, Brian, and thanks for having me. It's an absolute pleasure to be speaking here. And while I love digitization in all its forms, I'm eagerly waiting for when we can do these kinds of events in person again. So as you said, I come from the manufacturing industry, and I have a very practical view from when I think about AI, and that really focuses around decisions. Really, it focuses around how to derive value from AI. And in the manufacturing space, that really derives from making better, more accurate decisions, making them faster, and taking the decision and turning it into seamless, swift, and complex actions. Now, to do this, we can't see AI as a goal in itself. AI is larger than that, and it's key in a chain of capabilities. That chain is what I call AIoT. It's the amalgam of AI and IoT, taking real-time data, analyzing that data, pre-processing that data, running it through AI models, yes, scoring them, and then taking the output of those AI models and turning them into a decision model, and using that to integrate with operational systems, machines, maintenance systems, all kinds of machinery, all kinds of operational systems, turning that into actions that drive a factory, that drive a business. Analytically driven decisions drive that business value, and they have to be data-driven, accurate, timely, and embedded. That's what we're trying to drive towards. So, I've said the word decisions a whole bunch of times. What kind of decisions do we end up taking in manufacturing now? I've been a manufacturer myself. I've worked in many, many manufacturing companies. And the way I see it is there are multiple types of decisions that we make. Operational decisions, should I shut down my machine now, or can I let it run? Or am I going to face an unexpected shutdown 3 days later? Can I ship this product that may have misprocessed? Do I rework it, or do I have to throw it out? Do I take action now, later? Because every action has a cost. And I don't know, I want to be sure that I'm taking the right action at the right time. Should I be maintaining my machines every 3 months, 6 months? Now, as you see, as I'm going through these questions, when you think about them, some of these are fast answers. I need an answer now. Should I shut down my machine now, or should I let it run? You need that answer in seconds or minutes. When you think about how should I change my supply chain, should I localize my supply chain? That's slow, but that's still an operational decision. On the other side, your strategic decisions which impact the business. Should I enter a new market? Should I change my business model? Should I run this new trade promotion? How much do I get back from that? So when you're a manufacturer, you're thinking about both these operational and strategic decisions, and each decision that you make ends up becoming money. It's either it'll end up losing you money or gaining you money, but that's the value of it is of making the right decision in the right time frame is very clear. In the middle are these architectural questions. How do I orient my company around AI? What are the technologies that I bring on board, or that I should bring on board? Am I experimenting, or am I operationalizing? Am I investing in operations, improving my operations, or improving my innovative capacity? These are the kind of questions that I work with customers every day, with manufacturers every day, to kind of get to help them navigate. Now, I don't need to tell you the situation that we've all been facing and how that's hit manufacturing. We've all seen the demand disruptions. In the early days of the pandemic, we saw toilet paper flying off the shelves, and all of these crazy disruptions that we saw that came from demand, because now people are at home, demand has changed. It's not going to office buildings anymore. It's now retail packs. Production lockdowns means factories have to decide how to manage these lockdowns, and supply chain disruptions. Trucks can't move. All of this has created it's accelerated a shift that we've seen coming. And 2020 has been a year when manufacturers have been moving very specifically and very fast from a focus around, hey, I want to see what's happening in my factory, to I want to be able to predict what's going to happen in my factory. And that's gone from a focus around dashboarding to now saying, I need to do predictive analytics. I need to rapidly forecast where my demand changes are coming from. I need to dynamically and live real time optimize my production processes and my supply chain processes. Now, key to that has been technologies like AI. Manufacturers are more and more looking at how can I use AI? How do I deploy AI? What does AI do for me? But adjacent to those are specific technologies that we have to talk about. And I was really happy when I saw many of these technologies talked about in your word cloud. Cloud, being able to bring AI to the cloud and to the edge, streaming analytics, being able to operate in low code and no code, as one of the speakers was saying. Manufacturing doesn't have, just as an accountancy, the manufacturing today has different levels of AI readiness and the ability to capture talent. So it's a large part of upskilling talent into being able to use AI. And one of the main important areas is GUI-based development. Technology stacks and open integration, because there are And there are a large number of technologies involved here, and being able to integrate into those technologies is very important. And most importantly, ROI, coming back to where is the value? How do we, these investments that manufacturers are going to make are fundamentally different from the investments they make in the past. It's easy to buy a machine and say, well, this machine gives me 10% more capacity. And that, you know very well how that plays out. But how do you think about technology capabilities that are going to drive your business in the way forward? So all of these things are coming together today, and 2020 and the pandemic has accelerated that conversation. Let me give you a few examples of how manufacturers have been using AI. Now, this is an older example where, this I'd have to give you a little context around this, but this is a motor which employs an active magnetic bearing. This is in a case in a refinery where this motor essentially runs the refinery, and there are 20 of these or so. Now, every time there is a downtime event in that factory, production stops, and the total cost of actually the lost production plus bringing the machine back online, that's $1 million. Every time it trips out, the people have to now pull down the line, open up the machine, figure out what's gone wrong, replace parts that may or may not need to be replaced, and they have to dismount that. And it's time consuming. It's very costly. So the company is really focused around how do you predict the failure of that individual sensor. I may not be able to stop the failure, or there may be strategies, but I want to be able to mitigate the effect of that. Now, if you look at the conventional wisdom, it's to say, well, all machines degrade on a smooth curve, but that's not how machines truly behave in the field. So one of the ways to fix that problem was taking all of the data that's coming off the sensors on that machine and turning that through an AI model into a single indicator variable using various techniques. Using that, this company was able to, and working with this company, we were able to detect a clear signal to when the machine was going to fail. And that failure, that signal we were able to capture that 10 weeks in advance. Now that is huge because the company was able to do a few things. They were able to reduce their mean time to repair from 38 days to 10 days. That's a huge saving, which means that instead of the machine being down for 40 days, it's now down for 10. And beyond that, they were able to increase the life cycle of the machine because if you do maintenance early, you're not allowing as much degradation to happen in the machine, and you then have to replace less parts. So it was a clear win for this company to use analytics to be able to predict when the machine would fail. Now, this was quite a few years ago. Here's something closer to the present day, which is saying this is a drywall manufacturer who has a very specific problem. It's an old line, it's an old plant, but when you think about drywall or plasterboard or sheetrock, it's essentially construction material that makes the partitions in homes and offices. Each of these, it's like paper. Anyone who's had a printer paper jam knows the agony of trying to, get it out. And in this case, it costs them money. So let me see if I can play this video, and you can see a little bit of the technology Manik was showing earlier, but in a different setting. As you can see, we're detecting on the manufacturing line where each piece of plasterboard is and how it's beginning to overlap with plasterboard next to it, and where it's going to become dangerous. Now, if, for example, the plasterboard was to get too close to each other, and to the point where they're about to ride on top of each other and then go into the roller and jam, this will alert people to take the necessary action to stop the line. And in the future, could directly be interfaced into the line. What I love about this example is it didn't take weeks or months to do this because, rather than putting expensive sensors on the machine itself, which is essentially an old legacy machine, we used the feed from a security camera and ran that through a neural net to be able to do an edge detection to be able to do this. Okay, let me give another example from the semiconductor and the AI industry. Now, I like this because it shows you the actual formation of a digital twin. And we've often gotten used to the idea of digital twins being these nice 3D representations without thinking about what goes behind a digital twin. Now, in this case, imagine that I'm an engineer sitting at a repair station, a rework station for motherboards, because when people make motherboards, when factories make motherboards, they don't get them right all the time. In fact, yield rates can be quite low. You can't throw out an entire motherboard; it's really expensive. So repair is required. So in this case, for an engineer, behind this digital twin are predictive models that are running and classifying based on data from the testing of the motherboard. What is the likeliest chance of which component is wrong? So it's really looking at every component and saying what is the likelihood that this is the one that caused the problem. And with that, the engineer who's actually doing the repair now has clarity right on top, which says, here's the problem. The 96% probability is my RAM dock. And then with the help of the digital twin, doesn't have to go and search for, where is RAM dock 3 on this particular model of motherboard. He can explode the digital twin, and it can give him quick and easy insights into how to get in and repair that component. So I'm going to fast forward. It's a slightly long video, but as you can see, it's possible for him to go down and drill down into this kind of representation. So digital twins are representations that make it easy to work with, and they can be representations of production or shop floor. But digital twins using AI really bump that up to the next level. It says, I'm not just going to show you something, I'm going to tell you what needs to be done. Now, here's my last case that I want to share with you today, which is really focused around not just the act of manufacturing something, but the fact of manufacturing intelligent products that help customers. Now, this is a locomotive on a train, and if you think about a railroad, one of the costs of running a railroad and trains on a railroad is that you have to maintain the tracks, and it's often difficult to know when you have miles and miles of track where maintenance is most urgently required. So what you see here when I turn on this video is an AI model that has been trained on pictures of bad and good track. And from a camera that's sitting on a locomotive, it's taking it's analyzing each frame of the video, and it's telling you, it's giving a clear indication of where the track is bad. Now, this is amazing, but this is amazing in terms of, well, this is great that we can do this. And now you run a locomotive on a track, and you know where you want to send your maintenance crews. But the interesting part is that we are doing this working with a company that manufactures locomotives, and this is a product. This is a service that they want to supply to their customers, the railroads and the train companies, saying this is a way to take AI into our product and monetize that as an augmented product that we are now providing to a customer, solving a customer's major business pain. And we see that more and more as in the manufacturing space. For appliance manufacturers, for equipment manufacturers, all of them are looking to how can we build new service models by monetizing AI, data and AI, and into our products and building out more capabilities there. Now, of course, there are questions around data privacy, etc. But every manufacturer is thinking about this today. So, what is the entire methodology of providing, of operationalizing AI and creating this AIoT lifecycle? I'm not going to spend too long on this, but really it starts from what data do you have, preparing that data, exploring that data, modeling that data, where is the actual job of developing AI models. And most people stop here and say, well, this is what AI is. But no, it's beyond that, because then there's a question of managing and making sure the models that you're using are mission critical, are well taken care of, are registered, they're deployed correctly, which means that if you need a model to deploy in the cloud, in your data center, or right on the edge of a locomotive, which is where the last case I was showing you, the model is actually running on the locomotive without a connection to the cloud. You want to be able to monitor and retrain those models, And you want to be able to take the results of those models and turn them into decisions. In this case, where do I send my maintenance crew? And you also want them to trigger actions within the maintenance organization, etc. That entire process, that life cycle is going to be important to manufacturing, because these are mission critical systems, mission critical operations. No, that operationalization is key, and that's where manufacturers want us to go. So what we hear manufacturers asking us for here at SAS is, 2.0. We want to go from dashboards to real-time intelligence, AI-driven decision support built into those dashboards. Manufacturers still want to interact with dashboards, sure, but they want those dashboards to be much more intelligent. Specificity to business challenges, so digital twins that are very specific to operational business challenges. Integration into operational and transactional systems, which is really saying, I want to operationalize AI so that I can take those inputs from those decisions I get from an AI and turn them into actuation, into operations immediately. Collaboration and democratization of data, because manufacturers suffer a lot from data silos, and they want data and analytics to come together in the organization. So expert data scientists and citizen data scientists can work together. And all of this is in aid of increasing, today at least, increasing resilience and innovative capacity. I mean, the cost equation is there, but with the pandemic, what we're hearing more and more is increased resilience is the key area that manufacturers are looking for. Now, my last slide of the day, the AI community is responding. We're seeing multiple disciplinary skills being developed. It's no longer just about AI, but it's about data engineering. It's about machine learning and deep learning for sure. It's also about forecasting and optimization and integrating machine learning into forecasting and optimization methods. One of the things that the AI community is developing more and more, and in the last few years I've seen this, is the domain and business understanding. And companies that, ISVs, technology vendors, etc., are bringing on more and more people who understand manufacturing at a deeper level. Six Sigma, Lean, advanced process control, manufacturing execution systems, yield, etc. One of the key things that this also brings is a focus on model interpretability, which I think in the starting videos we saw a little bit about. Being able to say why did a model predict this way is key to many legal and legal safety, etc. issues. And being able to do that is very, very important. And addressing the entire analytics lifecycle, being able to deploy where you need to, whether it's on the cloud, on the edge, or in the enterprise. Being able to have open integration. So you're now integrating into possibly legacy SCADA or DCS systems, possibly new proprietary systems, and having APIs to connect with existing systems like a maintenance system, like an MES system. And most importantly, to be able to do governance and monitoring. So these are all the things that are top of mind when we think about manufacturing and AI. So I think that's all I'm going to have time for. I may have already exceeded my time, but thank you for listening, and I'm happy to take questions in the panel later. Thank you.
Thank you, Suraj. I think that was really interesting. We could see quite a number of examples of AI being used in manufacturing, and I think you're right there. The question that manufacturers are asking, how can they use AI to improve their business? That's the million-dollar question, isn't it? And I'm also happy to say that one of our partners for this DX series is the SMA, Singapore Manufacturers Association. So some of you from SMA out there, I'm sure you have enjoyed this. Another partner that we have for this DX series is the Singapore Academy of Law. So we have lawyers and legal professionals out there also listening in. And next up, we have Jeffrey Lim, who's a director lawyer at Joyce A. Tan and Partners. He is going to talk about big data and AI and legal. Jeffrey is a TMT and IP lawyer with an edge in regulatory matters, including data governance, cybersecurity, privacy, and data protection. He has worked with clients across multiple industries and across multiple jurisdictions. And so Jeffrey is going to share with us on the use of big data and AI in the legal industry. Jeffrey, over to you.
Thank you, Brian. I'm going to share my screen. Brian, can you see my slides?
That's right. Good.
Okay, good. Okay, good. So, lawyers we're in the business of holding people to promises. So when the title was suggested to be the promise of big data and AI, I thought the first question really that we should address for our audience is to understand whether we can hold AI to its promise, what it promises to do for legal work. So what I think we should do today really is really drill down as to what AI can and cannot do. And perhaps the way we should think about AI is not to think of it as artificial intelligence, but more augmented intelligence. Now, let me just drill down to discuss certain use cases that have surfaced for AI in legal. Now, this slide is not mine. I don't claim credit for it. It's by Cognilytica. And you can tell that it basically sets out on the left side of the screen some bold promises as it relates to AI, at least in legal. For one, there's this glaring number that says that there'll be 100,000 number of legal roles that'll be automated by 2036. 2036 is only 15 years away. So that's quite a bold promise. It basically means that we're going to reshape the entire legal industry. There'll be no role, or virtually no role, left untouched. And the other claim it makes is that there's a 94% average success rate of AI doing legal risk assessment tasks. And this is important because when we look at that idea, what is legal risk assessment? What is it that they're saying is leading to success in review of that risk? That always made me wonder when they said 94%, because if that's true, it's quite possible that that's much higher even than, say, human beings, because human beings do make mistakes, and there's a lot of difference of opinion as to whether you got that right or not. But we'll leave that aside, and I wanted to see on the right side of the slide 8 use cases that have surfaced, and these are fairly common use cases for the legal industry. I'll start with one, which is the automatic invoice generation. This isn't an area that doesn't get a lot of attention, but it should, because AI is actually, or rather analytics is certainly becoming a bigger part of running a legal operation. So if you're an operator of a legal business, big data does in fact give you more handles around how your practice is performing, and it can help support back office functions. Well, we often think about AI doing legal work, but actually AI and big data can actually support the doing of legal work, of the business processes. So automatic invoice generation was one use case that's raised, and I think it should get more attention than it's getting. But there it is. There's one thing that could do to help, in fact, trim a lot of costs from legal practice. And it really is also helping management teams, I think, understand better. For example, where is the revenue coming from? What is the growth areas? Can they do year-on-year comparisons in terms of revenue growth? Data capture in terms of the growth in the spend by a particular client on a certain firm. All these could be very useful data points, and it's good that we can see more practice management solutions which are emerging that allow this to be executed. And that really is about tapping into data and the promise of big data. There's another set of tasks here, and these are the ones I've just highlighted in red. And this has to do really with what I sort of consider technology-assisted review. So on the one hand, you could see that on the predictive coding, AI is ranking the relevance of documents. This has been around for quite a while, but it's getting more and more obviously sophisticated as the years go by. And relevance of documents has to do with how you execute your search functions, what you choose to be the focus. It gives you clustering of certain probabilities, of certain relevance rankings, and it gives you a better way to map and structure the information that you're given. And this is very important in legal work, because if you're a small firm or a small team that's faced with mountains of documents or information, you need to make sense of them quickly and in a time-efficient way. This does help. And legal research is a similar way as well, using algorithms to help sift through materials so as to flag them up for your attention. And that's true with the IP search assistance as well, where you dig through patents and identify portfolios and reduce search time. And this is already about relevance management and handling and curating data. Contract review is a particular extension of that, where basically the document or the AI would read contracts, bulk contracts, thousands of documents in the blink of an eye, and start turning out various identifications of certain spots that you arrange. So for example, missing clauses, mistakes, anomalies in contracts. The more ambitious application is predicting legal outcomes. This is more than just mere relevance ranking and curation. This is actually moving towards taking steps forward and identifying potentialities. Prediction becomes more important. And then the last bit, voice assistance as AI self-help services. This is where we are moving into a spectrum where there's a lot more interactivity and there's a lot more empowerment in terms of the technology. So in fact, if you spread these out, you can kind of see a spectrum. And this chart shows you the kind of spectrum that I kind of organized. You can start with the very basic on the left, where you have very little autonomy or control by the technology, and you go across the spectrum and you entrust more and more of the work, the legal work and the legal operations work to the machine. So on the left you have practice management, and there, you know, the practice manager, it's really identifying information, pulling out reports in an intelligent way, and potentially giving you more access and insight using the data that you have. And then technology-assisted review and drafting, where a lawyer is still very important, doing work and looking at the results dredged up by a particular review. And this could include very commonly used things which are now in practice, things like due diligence, e-discovery, where you go through massive documents and you can really bring yourself and your focus down to very important key points rapidly. And that has actually improved and given a lot of benefits to, and driven growth in legal work solutions. And then interestingly enough, you have predictive analytics that you can think about in terms of case outcome analysis. You're starting to replace a little bit more of the lawyer's process in understanding and sifting through ideas and probabilities. And then you go into the perhaps what might be more of a holy grail, which is where ultimately for certain legal processes, you have human out of the loop arrangements. So for example, if you were to talk about contract assembly, completely automated, intelligent draft, first full draft, where virtually no mistakes, and you could think about pulling that out as one of the end goals that you're looking for. And then you have chatbots which do the work of providing solutions. So this is a spectrum that we're moving across. And interestingly enough, different companies are playing along different sides of lengths of the spectrum. Now, but before we get to that holy grail, before we even think about how far that will go, I think it's important to understand what we're really talking about. And for the non-lawyers in the house, I think it's important to understand, to see how, in fact, the use cases do get impacted by realities, by nuances. So consider contract automation review. Now, what can AI do? Let's say you have 1,000 documents, all with a particular clause, and you want the solution to analyze these clauses in microseconds and then pick out certain things. And what it finds is the following differences. The first clause says party A will not be liable for any delay, except if the delay exceeds 30 days from a certain particular date. The second example is, well, party's not liable, except if the losses exceed 1.5 times the delivery price. So it's still pretty objective information you can look at. The last part is party A should not be liable, except to the extent that the delay is reasonably foreseeable. Okay, so what can we do with AI? Well, first thing is easy. We can spot the differences in the contracts. There's enough in technology today to actually pull apart the contracts and identify where they look different, where there are nuances and differences. And they're getting more sophisticated all the time. They can analyze some of the key variables in the language. What about identifying where contractual breaches have risen? So if you look through all these contracts in the due diligence, you want to know, did this company have risks? Or is it likely to face a claim? Well, whether breaches have arisen isn't something you can pull off the page in itself. You might need to think about being able to identify information sitting elsewhere. So delivery receipts, or due orders, or even letters of demand. That's documents sitting elsewhere, and that's something that you would need to drill down and pursue following through the line of inquiry suggested by a particular review. It's not outside the realm of possibility that this could in fact be automated and happen, but certainly it isn't there at this point yet. Well, what about identifying contracts where the losses have actually exceeded exclusion limits? Again, it's a similar nature. You look at where losses have arisen based on information given in the data room, if there's any, and then you determine which other contracts where it links to. That too hasn't quite surfaced, but we can see that that's something that can be executed. But then what about identifying causes for delay for which the exclusion does not work? And this relates to the last clause where the delay is reasonably foreseeable. This is where you go into a realm of qualitative decision assessment, which can be quite difficult and slippery for machines to do. And I'll explain that a little bit later, but you can see that essentially, when it comes to AI legal work, if you look at, say, contract due diligence use case, there's certainly a wealth of differences that you can identify in situations you can find yourself navigating using the tool. And I think the experience so far in some situations is certainly that if you're talking about commoditized or contracts, and these are contracts where very few things ever change, it's a very set way of doing things, it's easier to manage a lot of that very quickly and make even more intelligent decisions around it and perhaps entrust more of the control to the spectrum. But if you're looking at bespoke contracts where there's more negotiation, that's going to be a bit more difficult. And you can consider that level of complexity too as it comes to transactions. So in order for you to successfully adapt and apply the AI solutions, really you need to go back into expectation setting and understand what kind of thinking is needed in law. For the non-lawyers among us, I think one thing that we lawyers always have to wrestle is when we see courts tell us each case must be judged according to its own facts. In that kind of situation, it's just not enough that you just have access to mere data. You're actually doing more than that. You need to see connections and use your intuition and your experience. And that is really important to show. And I'll give you two brief examples where this lateral thinking in law and intuition is important. One's an old case, and I'll just give you an explanation. This is a brick wall, and you see them in some old HDB blocks, right? The particular case I had in mind was told to me by an old practitioner from days of yore. And he told me that he was involved in a particular criminal investigation once where the assailant was accused of the defendant was accused of giving a knife to the killer, who then knifed the person. And he handed the knife over while he was in the staircase. And outside the staircase, really, you had this wall, and it had these little perforations in it. You could only see parts of things happening. And the key eyewitness made the claim that she saw the person hand the knife to the killer on the stairwell. This particular lawyer decided to go out and take a look, to do a site visit, and found that this was the type of wall he saw. And it was really there that he discovered that there's something wrong with the story. And he took a picture, he brought it, he confronted the witness in the cross-examination and said, this is the wall, it was nighttime, so did you really see it? And the witness at that time realized the impossibility or the difficulty of actually being clear about what she saw. And she said, well, I heard the killer hand the knife over, which changed the testimony and then unfortunately resulted in unfortunately, it resulted in the acquittal. If you think about it, it was the lawyer exercising some lateral thinking, not taking information at face value and independently finding another source of information that would enhance the discussion and review. So we're also talking about working off data, sort of the meta level, where you find connections that are really about exploration, about intuition, about creativity. This was not too different in a big data situation. I don't know if you've read of this case. There was a murder trial where an Apple iPhone was used to help solve the murder. The defendant, Mr. Hussein, claimed that he was innocent. But interestingly enough, they managed to get his iPhone eye health data, and they found that on the moments of when he was accused of perpetrating the strangling, he had murdered the victim violently, his health data actually tracked a burst of activity, which Apple could only assume and identify as him climbing stairs. but yet that was enough corroborating evidence to twin it with the eyewitness and all the other stuff that the prosecutors could in fact draw the connection that actually you were involved in taking and doing the murder. So that tells you a little bit about the nature of legal work. It isn't just the text on the page. It is an assessment that goes beyond that. Now, certainly computing power and the sophistication of legal solutions are going to help us get more data, are going to get us more access. I could nowadays potentially go to visit the HTTP block and see that image if I had Google Maps, potentially. Maybe I could do that. But at the end of the day, legal work is all about that lateral thinking outside the box, looking behind the data. And this could be something that we should consider when we think about the promise of AI. You can't press a button and get a really in-depth and well thought through legal risk analysis. It does boil down to someday to real practical experience and everything that comes from our human experience. Now, for the rest of it, new jobs will emerge in the legal sector. That's not an overstatement, I believe. The first slide I showed you, that there may be many jobs that will disappear. Many new jobs have begun to appear already. And then new transacting models will emerge. But technology that we have, more decisioning could be built in. Legal contracts and the nature in which we transact can change because they will become more process-oriented. And when you script the contract, it isn't necessarily just a series of documents. There could be, in fact, decision-making and coding that goes into that whole element. And then we have to think about new ways of thinking about processes themselves. And as we do so, there'll be new issues. We already know that currently in data and in AI, there are issues of privacy. There are issues of the free flow and ownership of data. There are issues as it relates to various interactions with various laws. Okay, so that brings me to the end of my presentation, and I'll hand it back to you, Brian.
Thank you, Jeffrey.